Kia ora. I just got the 2022 algebraic methods paper, so let's get into it. I'm going to go through and do all of the questions, and yeah, there could be mistakes. I'm just doing it as if I was sitting the exam. So let's solve this one. I'm going to times everything by x plus 4. I'm even going to write it over here, why not? 2x minus 3 minus 3x minus 12 equals 0. Solve. Okay, so we've got a negative x, I should have brought it over to the other side, minus 15, negative 15 equals x. Yeah, I mean, I'm just going to go fast and leave my mistakes, I won't even check them. Factorize completely. Ooh, okay, so we can pull out a 3. Can we pull out more than that? No. We can pull out an x squared. Ooh, we can pull out a... I'm going to pull out a y to the power of a half or a root y. I'm going to pull out root y. And that's because root y times root y equals y. So I'm pulling that out. 3 times 2 x squared times x, q square root y times square root y, minus 5, no x's and no root y. Looks good to me. Simplify fully. No like terms that I can see. I'm just going to split them up. Minus x minus 12. I'm going to do this method today. Negative 12 times 6 is negative 72. Is it like a 9 times 8 maybe? So I'm going to go negative 9 and positive 8. Is that right? Ooh, I'm questioning myself. 6x squared minus 9x plus 8x minus 12. And then we can pull out a 3x. And that means we've got 2x minus 3 plus, I'm probably going to pull out a 4, and then we get 2x minus 3. 3x plus 4 in brackets, 2x minus 3 in brackets. I thought I'd left enough space over here to do the other one as well, but I haven't really, so I'm going to do it down here. 3x squared minus 5x minus 12. We get negative 36, and then to get a negative 5, is that like a 12 and a, a 8 and a 4? No, 9 and a 4. Minus 9 and positive 4. Should I check it? No. 3x squared minus 9x plus 4x minus 12. Why am I doubting myself so much today? I don't know. 3x, x minus 3 plus 4x minus 3. Looks good. Equals 3x plus 4, and there's your link. X minus 3. So this is equal to, on the top we have our 3x plus 4, 2x minus 3, and on the bottom we have our 3x plus 4, x minus 3, and then we can simplify that to 2x minus 3 over x minus 3. And that is fully simplified. Yep. Okay, next question. This is the one that I had a student complain to me about. It's the only thing I've heard a student say looks tricky. A calendar can be presented in the following way, where each day is given a number from 1 to 365. This is the beginning of a year's calendar. Joe draws a 4x4 square on the calendar to check a claim that she heard. The sums of the diagonally opposite corners are always the same 39 plus 21 is equal to, no matter where you make your square, 18 plus 42. Why is that true? Because this is going to be that one minus 3 times 7, and that one's going to be that plus 3 times 7. Wow, tricky. It's not even cool. I don't know, I guess it's cool. I like it. Minus 3 times 7 to get to there, right? And then this one is, yeah, that's why. Minus 3 times 7. Okay. In other words, when you add the numbers in the orange corners, it is the same as when you add the numbers in the blue corners. Joe wonders if the claim will still be true no matter where she starts the square. She begins a investigation using algebra. Yeah, okay. So then that's a plus 1 plus 3. And then this is so then below yeah, it's like formalizing it. That's kind of hard. Use algebra to prove that no matter where it's drawn on the calendar, the sum of the orange corners must be the same as the sum of the blue corners. That's a plus 3. This is a plus 7. This is a plus 14. And this is a plus 21. This is a plus 10. This is a plus 17. This is a plus 24. A plus 24 equals a plus 3 plus a plus 21. 2a plus 24 equals 2a plus 24. I don't know if I'm doing. Is that? I don't know if that's enough. I feel like I need to use like some words to explain how I knew that was a plus 7, a plus 14, a plus 21. Maybe I need to do like fill in these. Yeah. I don't know. I'm pretty happy with that. Joe wonders about the products of the diagonally opposite corners. Could they be the same? Whoa. That it is not possible to draw any 4x4 square for which the products of the diagonally opposite corners are the same. A plus, I don't know, I really don't know if I'm giving enough information. I don't know if I'm proving anything. A squared plus 24 a plus, wait a second, 63. 0 equals 63. Therefore, impossible. I don't know, is that enough? This is any 4x4 square. I could draw a 4x4 square. What about this bad boy? You guys like this one? What if I get this and I put a 1 there, a 1 there, a 1 there? Oh my gosh, the diagonal products are the same. Any 4x4. I feel like I've proved it here. Whatever number A is, this will always be the resulting other numbers. No matter which A I pick, it will satisfy that. So I think that's enough, which is annoying. Oh, I'm moving on. I'm done with that one. Will it always be true that the sum of the orange corners, okay, must be the same as the sum of the blue corners, regardless of the size or shape of the rectangle Joe draws? By an n by n rectangle drawn on the calendar below, where m and n are whole numbers greater than 1, n does not equal n. You may wish to draw a diagram on the calendar or beside it to help explain your reasoning. Ooh. Okay. Any. Shucks. Okay. So I guess we're sticking with A in the corner. We're going to stick with A here, but then I'm going to fill in these with dot dot dots, and this is going to be does it matter? Does it matter where m and n are? Does it matter? M by n. I'm just going to call this m, and this is n. So this would be, is it m minus 1 to the end, or is it a plus m to the n? I'm just going to cut it. I'm going to say it's m from there actually, just so I can make it a plus m. I want to make it as simple as possible. I'm going to cut this one off here as well. This is, what is that? That's a plus m. But doesn't it goes across to m, and then it's a plus m plus 1, and then that's a plus m plus 1. Ugh, man, okay, this is kind of hard to get your head around, isn't it? Then it goes across to a plus m. The new line is a plus m plus 1. And then it goes across to here, which is a plus m, a plus 2m plus 1. I kind of just want that to be a plus 2m, but I don't think it is. Because what's the system that happens here? This is a, this becomes a plus 3, and this, when it finishes the, is it any rectangle within the 7? Is it still any rectangle? Okay, I'm just going to do an example one just to get my head around it. And we're going to choose these. Are they the same though? If it's 7 by 7 I lose. Nice. It's 6 by 7. So let's go with this one, because we start off with a 4, which is our A, and then m equals, because I should label it really that m is 6, but I kind of want to make m 5. Nah, I'm going to make m 6, so this is actually going to be wrong. We'll call m 6 and n 7. So then this is actually a plus m minus 1. Yeah, and then that'll get rid of these. Yeah, that's kind of nice. I think that's nicer. A plus m minus 1, because then that makes this a plus m, which is way nicer. And then that makes this What does that make this? 4 plus a plus m should be 10 minus 1, and then the next one is just a plus m. No, it's not. It's still a plus m plus 1. But why is it plus 1? So then the end, it becomes a plus 2m, which is 12, and then it keeps going down until at the end it is 7 times 6, 42. Oh yeah. A plus nm is here because it's 4 plus 42. I don't know, I just want to know why that's there, because that's a plus m plus 1. This is a plus 2m. Why? What have I done wrong here? It is a plus 2m, right? Oh no, it's not. Plus 2. About 8. I gotta get my head around this. 12 plus 4, 16, and then plus 2. What am I adding on the 2 for? These missing boys. Ooh, I have not got this down. This is definitely a plus nm, and this corner is a plus nm plus m, is it? 4 plus 42, 46, plus 6. Whoa, minus 1. I'm not feeling this question, eh? I just need to, okay, so this is my theory as to what it is, but let's do a rectangle that's like can't go wrong. Let's do this rectangle here. So we start off with a, and a is 57, m is 2, and n is 3. So then it goes a, let's just do our corners, and then this corner is a plus m minus 1, yep, and then this corner is a plus 6, is it? No, it doesn't work. Does this one work? 4 plus 42, 46. Oh man, thinking so hard. If you were doing this in the exam, I would move to the next question at this stage. I need more time to problem solve this. I'll come back to it. Okay, question 2. Quadratic equation has these solutions. Find the values. Okay, Okay, there's a couple of ways to do this, but I think the nicest way to do it is x1 equals negative 2 over 7. 7x1 equals negative 2. x1 plus 2 equals 0. And then we'll go the other way. x2 equals 1 over 3. 3x2 minus 1 equals 0. So let's go like this. 7x plus 2, 3x minus 1 equals 0. 21x squared minus 7x plus 6x minus x minus 2 equals 0. Does that look about right? Let's factorize it. Just want to double check this. Plus 6 minus 7. 21, negative 1, negative 2. What is the discriminant of the equation? Bleh. B squared 144 minus 4ac 14, 28, 56. 144 minus 56. 6 plus 6, 12. 100 minus 12. 88? Suppose this, with this, what value okay with the equation? Y equals 0 have exactly one solution. Discriminant equals, is it that? No. 144 minus 4, 2k. 144 equals 8k. 144 over 8 equals k. 72, 36. 18. Okay, solve this. Get rid of the square root, surely. 2x plus 3 equals 9x squared. 9x squared minus 2x minus 3 is equal to 0. Negative 27. Need to negative 2 somehow. Like 27 is only a 3 and a 9, isn't it? So I thought I'd get to 27. Have I done something wrong here? Square both sides. That gets squared, that gets squared. I'll pull this over. 9 times negative 3 is negative 27. I don't know. Could use the quadratic equation here. Polynomial, but I'm just going to use this. I think it's not nice. What the heck? Have I made a mistake? That's way too... That's ugly as. x1 equals negative 0.476. x2 equals 0.699. Hey, have I made an error here? Square it, square it. Minus 2x, minus 3. I don't know. It's ugly. Okay, suppose this function, yeah, the reciprocal polynomial of this is that. Yep. What? Find the solution. Fx squared plus gx plus h is equal to hx squared plus gx plus f. F minus h, x squared, they disappear, plus h minus f equals 0. Find the solutions. There's a middle term missing. What can I do? Seems like this should be. Oh, I can just factorize it. F minus h x squared plus 1 equals 0. Man, I don't know if my students would be able to do this very well. Some of them maybe, but in general it's kind of tricky. X equals -1, x2 equals 1. Is that right? Yeah, nice. Kind of cool. Okay, suppose that qx equals 0 has two different roots, a and b. The roots of the other one, the reciprocal, are multiples of a, b. Oh! Find an expression for k in terms of f, g, and or a. Am I setting up like a quadratic equation here? A equals negative b minus square root g squared minus 4f ec divided by 2f. B is the same but with a plus. And then the other one, Ka equals negative g minus, and the order could be wrong here by the way, b squared minus 8c divided by 2a. And kb squared minus 4hf over 2h. Find an expression for k in terms of the other boys. So what's cool here is the discriminant is the same for all of them. That's going to be handy. In fact, the top half of all of them is the same except for the pluses and the minuses. So I know b is that. I make like two b equals expressions, and do I just like chuck the k's at the bottom of these maybe, and then I can like say that negative g minus root g squared minus 4. I'm going to change around the direction. Over 2f is equal to that. Negative g minus g squared minus 4hf, but I'm going to put this over 2hk. So then I can say that 2f equals 2hk, and then f equals hk. Am I going to get more knowledge than that? Where's that at? So find an expression for k. So k equals f over h, I reckon. Because if I do this for here, I'm just going to end up with 2f equals 2hk, which is the same thing. I reckon that's it. K equals f over h. Shuck, I'm really not sure about this exam actually. I like it though, so far. It's exciting. Okay, simplify fully. 7y18. Solve the equation. Oh, fun! Log base 2 of 2022 equals x equals log base 10 of 2022 over log base 10 of 2. Log 2022 divided by log 2. Do I trust that? Yep. X equals 10 point. Oh, I'll show you what I was checking. 10.982. Simplify the expression fully, writing your answer as a single logarithm. Log of 3a plus log of a squared over 36. What do you do when you're adding? You just multiply them, right? Log of 3a times a squared over 36 equals log of a cubed over 12. Yep. Let's just consider the equation. Log base 2 x minus a minus log base 2 x plus a equals c, where a and c are constants. So that when x is made the subject of this equation, x equals that. Yeah, cool. Okay, I like it. Gotta bring these together. Log base 2 x minus a over x plus a equals c. Log base 2 of all that is that. Log base 2 of a thing equals another thing. So So what could I write? 2 to the power of c equals x minus a, x plus a. Is that getting me any closer to making x the subject though? I don't know. Can I multiply everything by x plus a? 2 to the power of c equals x minus a? I don't know if that's helping. Oh yeah, maybe. 2 to the power of c x plus 2 to the power of c a equals x minus a. I don't know if this is helping. 2 to the power of c x minus x equals negative 2ca minus a. How many a's we got? 1. Okay, so I need to factorize both sides. X 2 to the power of c minus 1 equals a negative 2 to the power of c minus 1. Oh yeah. It's looking like it's getting there. X equals a times negative 2 to the power of c minus 1 over 2 to the power of c minus 1. Okay, now we just got to make it look the same. What can I multiply? Have I done something wrong? I guess the question is if I've done this right. I don't really want to look at the formula sheet. It would be more fun to not. Okay, I just want to double check that I've done my log law right. Yeah, log with the same base is the first over the second. Yeah, that's right. That goes down and these guys swap over. That's right. If we have this, some number, that becomes the power, yeah. Log base of that becomes the base of the power, yeah. And then the thing that was up by itself, yeah. Looks right. Okay, so we've got some, we multiply both sides by x plus a, yeah. Then we expanded this, yeah. We minus x, yep. And we minus 2 to the power of c a, yep. And we pulled out an x and it became 2 to the power of c minus 1. There needs to be more positives around here. Like, if I put out like a negative a, it would have been all good. If I times the top and the bottom by negative 1, oh yeah, that's probably the way. A, and then it's going to be 2 to the power of c plus 1 over negative 2 to the power of c plus 1. Then I'll rearrange. Yeah, that's it. 1 plus 2 to the power of c over 1 minus 2 to the power of c. Yep, looks good. Okay, the equation bleh minus bleh is only possible to solve for some values a and some values of c. Oh man. So if c goes, man, this is a pretty tough exam. I like it. X is only, we can't take the log of a negative number. A needs to be greater than x. What if you take like a, you can't even have a log of 0. Yeah, so that's probably where we're going to start. A is greater than x because you can't take the log of 0 or a negative as log base 2 x minus a. I say 4. That's my first thing. C can't be 0. C cannot equal 0 because you can't divide by 0 for that 1 minus 2 to the power of C. Yeah, if that was 0. What are the reasons? That minus that equals C. I mean, I guess A cannot equal 0, but then they could just make x be 0. A cannot equal 0 because why is that? Log base 2 of x minus log base 2 of x equals 0. Thus, C would equal 0. Yeah, I mean, I think that's it. It could be more, but that's all I can think of right now. So I'm going back to this question because I could not wrap my head around it unless I'm doing it wrong. Okay. Well, always be true that the sum of the orange corners must be the same as the sum of the blue corners regardless of so I just need to generalize the corner values. I'm really not finding it. Is a plus m minus 1 always the case? 57 to 58, you add on the 2, and then you minus 1. Going right across from here, from 4 plus 6, yeah, it's 10, and then minus 1 to get you into the zone. So those are good. Those two are good. It's this bottom one that I haven't wrapped my head around. To get down here, we're going to be at 4. I guess it's always plus 7. Oh yeah, okay. Because it's always 7 wide. But if you start here, that bumps you, it's always plus 7 times n. Minus 1. Could that be it? Is that, let's test that. A plus 7 times n minus 1. Is that true? Let's try for this one. Because I go down 1, 2, 3, 4, 5, 6, whereas n 7. Yes. Okay, so it would be a plus 7 times 6, 42. Yeah, nice. And then to get across, yeah, I'm locking that in. A plus 7 n minus 1. And then get across to here, you're just going to get that and do the Same thing. No, I just want to go across m minus 1. A plus 7n minus 1 plus... No, that can't be right. m minus 1. Yeah, let's go with that. Let's go with that. Why not? I'm done. I'm done with this question. I'm done with this paper. Let's do it. I think it's it. So, a plus the opposite, which is a plus 7 n minus 1 plus m minus 1 is equal to a plus m minus 1 plus a plus 7 n minus 1. Okay, 2a plus 7n minus... Damn, my brain is farting. Don't do this, brain. You need to concentrate. A plus 7n minus 7 plus m minus 1. Yep, it's the same friggin' thing. Okay, I'm going to draw a really clear diagram of what I've found. Okay, so this is what we found. This is however long. And then this is our A. This one is A, you go M across, but you're not going M across because the full thing is M. So you're going 1 less than M across. Now going down, all you do is you go A plus, and each time you go down, you're going down because it's 7 days in a week. 7, and then it's that n minus 1, same as how we're doing m minus 1 over here. And then a plus 7 n minus 1 plus m minus 1. Yes, yes, yes. Okay, cool. That's it. That took me a while actually. 47 minutes. Alright, GG. It's been Mr. Forbes.